Number 34. A spring with spring constant equal to 150 Newton meters on an incline of theta equals 54 degrees is compressed a distance of delta x equal 0.06 meters along the incline by a mass of 0.042 kilograms and then released. What is the velocity when it passes the point where it was first compressed and loses touch with the spring? All right, so we have to set up the relationship between the energy at the point when it's fully compressing the spring from the start. We're going to have EPE plus an initial GPE, and then after its release, it's going to rise up the incline until it just loses contact with the spring. And once it does, it no longer has elastic potential, EPE plus GPE. It no longer has elastic potential energy. It just has a final GPE plus a KE. And the KE is going to have the velocity, and that's what we're looking for here. All right, so substituting in for our equations, we have EPE is 1/2 K delta x squared plus mgh initial equals mgh final plus 1/2 mv squared. At this point, we want to isolate our velocity, so let's get 1/2 mv squared all by itself and throw everything else on the opposite side. So we're going to have 1/2 K delta x squared plus mgh initial minus mgh final. Okay, so at this point we could say 1/2 mv squared equals 1/2 K delta x squared, and let's factor out the negative mg. So negative mg times h final minus h initial, or 1/2 mv squared equals 1/2 K delta x squared minus mg delta h. To get velocity by itself, we'd have to multiply both sides by 2 and divide by m and take the square root. So we're going to have velocity equals square root of 2 over m times quantity 1/2 K delta x squared minus mg delta h. All right, and to simplify this a little bit further, we would multiply everything by 2. So the 2 and a 1/2 are going to cancel, and we're left with K delta x squared over m, and the m is going to cancel here, but we still have the 2, so it would be 2g delta h. Now we can get rid of the delta h. K delta x squared over m minus 2g, and for delta h, we can say it'd be equal to delta x sine theta. Now we can start substituting in numbers. Velocity equals the square root of k, which is 150, times delta x squared. Delta x is 0.06. We have to square that. Divided by a mass of 0.042 minus 2 times 10 times delta x, which is 0.06, times the sine of 54 degrees. Simplifying that, we get velocity equals 3.5 meters per second.